Hello, good morning, good afternoon, and welcome. I'm very pleased to be joined by Thijs de Groot. Thijs is a technology developer at HyCC, a company which we'll understand a little bit about the history of the company. He's also an electrochemical engineer and an expert indeed, and has worked in this field for many years, and is indeed an associate professor at Eindhoven University as well. So welcome, Thijs. Thanks for joining.
Yeah, happy to be here.
So you're obviously an electrolysis expert. You're going to be speaking at the World Electrolysis Congress, which is coming up in Düsseldorf next month, March. Obviously, there's a lot happening in electrolysis, the scale up and development of a new industry. And obviously, HyCC is a new name, certainly maybe to some people. Can you give us a little bit of understanding of HyCC and the legacy and the history of the company and indeed your own background?
Yes, I'm happy to do so. HyCC indeed is a new name, only exists for one year basically, but we do have a long heritage. Our 50% shareholder is Nobian. Nobian is a company that operates chlor-alkali electrolyzers already for over 100 years. Largest plant of Nobian is a 200 megawatt chlor-alkali plant in the Rotterdam area. And we basically take this electrolysis expertise built up by Nobian, and as HyCC, we take it into the field of water electrolysis.
Right. And HyCC have got a project, that the H250 project with BP, in terms of is it 250 megawatt electrolysis plant under production or under development. And how can you tell us a little bit about that project and how you're finding the scaling of the project and some of the challenges that you see there?
Yes, so indeed, the H250 project is a project located in Rotterdam, where the plan is to supply the refinery of BP with green hydrogen, with an electrolyzer with a capacity of 250 megawatt. That's a large scale. The largest electrolysis plant currently in operation in Europe, I think, is 20 megawatt.
Mhm.
So we really have to do this scale up, and also the suppliers of the electrolyzer technology, they need to scale up, and that brings a number of challenges. Apart from that, another challenge is that we want to be able to provide BP with green electricity, and that also means, for example, the flexible operation of the electrolyzer plant, and that's not what we're used to in the chlor-alkali industry, where base load electrolysis has always been the standard, and now we have to move this to more flexible types of electrolysis.
And what are some of the challenges? I mean, obviously the flexibility, the reason for the requirement for flexibility is the offshore wind, your power source. And what happens with an electrolysis plant when you've got that variability, and what do you think some of the challenges are going to be, or are?
Yes, it depends a bit on the technology you use, whether you use alkaline or PEM technology. We're still in the process of deciding the most suitable technology for that plant. But for example, we have a lot of experience with chlor-alkali electrolyzers, which resemble the alkaline electrolyzers. And there you see, when you shut down an electrolyzer, then you suffer from what we call reverse currents. That reverse currents start to flow inside the electrolyzer, doing the opposite of what they should do, and that can, for example, lead to electrode damage. Also, when you have to shut down electrolyzers, they start to cool down, and later you heat them up again. That's also not you like. That's something you generally don't like to do with any chemical plant.
Yeah.
Heating up and cooling down is never a good thing. So those are challenges that need to be addressed, that are addressable, but it requires a proper design of the plant.
Mm-hmm. And I mean, in terms of some of the design elements, I mean, do you look to sort of build in more flexibility with batteries, or is that too expensive? Or also, do you think there'll be optimization with maybe two different types of electrolysis, or do you think it's just one platform only is the way to go?
At the moment, we are only looking at one electrolysis platform. We don't really see benefits in combining different technologies. We are looking into this battery option, but at the moment the conclusion is that is quite expensive. And also the footprint of the battery should not be underestimated. You need significant footprint if you would like to do that, and we don't. There's not so much footprint in the Netherlands, so we basically space for the electrolyzer plant. So yeah, so that at the moment that does not really seem to be an option.
Yeah. And in terms of handling that sort of quantity, 250 megawatts of hydrogen, I guess there's sort of safety aspects and some of those are they sort of challenges or?
Yes, safety is a key aspect in green hydrogen production. I think it still deserves more attention. I think it has to be been underestimated a bit by the current suppliers of electrolysis technology. In water electrolysis, you produce hydrogen and oxygen next to each other, only separated by a thin membrane. And there are scenarios, if you don't design your installation well, where hydrogen and oxygen can potentially mix. And that's something we want to avoid at all costs. That is possible, but it does require a proper design and also proper evaluation of all the safety aspects of such a plant. And that's what we are doing with potential suppliers of well, H250 is one of our projects. We do have more projects in both the Netherlands and Germany, where in every project we look into safety.
Excellent. And I mean, in terms of that mixing, is that an issue with the oxygen going into the hydrogen and becoming impure, or is it a cause for an alarm from a safety perspective?
Yeah, there are basically two aspects to this safety aspect. There is always continuous hydrogen crossover through the separator from the cathode side to the anode side. That leads to basically the pollution of the oxygen with a bit of hydrogen. At nominal loads, that is no problem for the electrolyzer. But if you really take it down to a very low load, the electrolyzer, then you produce so little oxygen that this hydrogen, yeah, the concentration of the hydrogen basically gets too high, and you get into the explosive domain. That's not where you want to be. So that means you need to shut down your electrolyzer. That is normal operation. There are also scenarios which are very rare, only happen in 1,000 years or so, where there is somehow you have hydrogen, you have gas liquid separators, one containing hydrogen, the other one containing oxygen. And there are very rare scenarios where in which the contents of these two vessels can mix. And if that would happen, that would really be a serious issue. So that's that latter one we need to avoid at all costs, and that's what we design. So there are basically two aspects to it.
Yeah,
what I
understood. Well, I think there was going to be a lot of discussions, and all the discussions as this industry, builds and scales. Certainly looking forward to a lot of discussions. You're in a panel yourself at the World Electrolysis Congress, so we're looking forward to it. So thanks a lot for taking the time out of your day to share some of your thoughts today, and we look forward to seeing you in Düsseldorf on I think it's the 14th, 15th of March. So many thanks, Thijs. Take care, and good luck with all the work.
Yes, thank you. I'm looking forward to the conference.
Yeah, cheers.